what is traversable network. So before we go for traversable network, I would like to introduce what is edge, what is vertex, what is region, what is degree of the vertex, and what is network. So if we get to know what are those, then it's going to be easier for us to understand what is traversable network or traceable network. Okay, so I'm going to work out with edge right now. So and at edge, a line segment representing a bridge. So I'm going to actually construct an edge. So as you clearly see, point A to point B, this is an edge. Okay, now I can actually have another one, point A to point B, like that also. So this is point A to point B, and I can have another one also like that. I can have another one, point A to point B. Look, this information is useful in graph and network and graph theory. Okay, even though this is like network and graph theory, this has all been everywhere used. If you drive, if you have seen this, you walk down, and of course, obviously, you see a street that has a straight line. Some streets are not a straight line. You go point A to point B, your house to another house, not always a straight line. You have some curve, and you have some one house to another house, but it can be a curve or it can be a bridge. So it's connecting two points, as you clearly see. So this is all sort of line that represent an edge. It doesn't matter how big, how small, as long as point A to point B, the dot, actually that represent the edge. So let's have more example. Okay, so I'm going to actually create one here. So this is one edge clearly, and I can create another edge. So this is my another edge actually. Okay, and I can have an edge like that. Okay, clearly, and I can have an edge like that, as you see. So this is just a bunch of edges down here. So I can count 1, 2, 3, 4 edges. And of course, we're gonna learn what is the vertex. So those dot we're gonna call vertex, and actually why we call the vertex, let's take a look here. Vertex are points where the edge met or cross. So, or points, sometimes we refer to nodes. Okay, so NODS, nodes, where the edge is met. So well, let's take a look here. So this is the very simple one, which is a triangle, and clearly the line segments points where the edge. So this is the point, and these are two edges meets in this point. So this is a vertex. This is a vertex. Why? This is two line segment meeting this point, and this is also a vertex. So I can level it actually. A, B, C. You can level it your own. Okay. I'm going to have another one actually up here. Let's have a triangle here, and I can create another one here. A, B, C. So is this our number of vertices same as last one? Yes, obviously. This is the vertex, this is the vertex, and this is the vertex. And this is just a line segment. You have seen it can be arc, it can be curvy, it can be bridge. Okay, so that's a line segment. All right. Now let's take a look here. One more. Okay, so A, B, C, D. So clearly we have 4 vertex here, as you see. 1 vertex, 2 vertex, 3 vertex, 4 vertex. By the way, if I recall, there is 3 edge, 3 vertex. Over here is 3 vertex, 1, 2, 3, 4 edge. Up here, there is a little bit confusion. We clearly see number of vertex here, 1, 2, 3, 4 vertex. But how many edges are there? 1, 2, 3, 4 outside. Some students say, oh, there is a 4 inside. No, that's not correct. It's A to B, sorry, A to C, and of course B to D. That's created clearly. So I want to make sure that we understand. So A to B, that's 1, 2, 3, 4 vertex. Sorry, 4 vertex, as you see, is connected. Now this is an edge. So this is 5th. Point A to point C, only one edge. It's not a 2 edge, and this is only one edge. Remember, there is no dot, there is no edge here. So in this case, we have 2 plus 4, 6 edge. I'm going to create another one here. So let's see, we have more understanding on this one here. Let's have diagonal and diagonal here too, and label it A, B, C, D. And of course, I'm going to have something inside. So clearly you see up here, well, they said cross, okay, crossing, mat or cross. So over here, this is a crossing, as you see, D to B, and of course there is a point here, as you see, even though this one is crossing, but this one doesn't have a point. So I meant points where the edge met or crosses. So this is no point, so we don't consider them a separate edge, only one edge. This is a point, so we do consider all of them a separate edge. Okay, so I will have to come up with this one here, A, B, C, D, E. This point is E. Okay, so I'm going to actually check out down here. Okay, so this is one edge, two edge, three edge, 4, 5, 6, 7, 8 edge. Clearly 8 edge. So edge 8. Vertex, well, I would say vertices actually. Vertices actually. Vertices in this case is 5. And this one edge, how many edge? This one is 1, 2, 3, 4, 5, 6 edge. 6 edge. And vertex or vertices, well, vertices in this case is still all this 4. Now up here is edge. How many edges? 1, 2, 3, 4 edges. And how many vertex or vertices? In this case is 3. Up here is edge. How many edge? 3 edge. Vertex is also 3, clearly, as you see. So that's how we actually work it out. Now, before I move something else, I would like to show you another one here, another tricky point from this one to this one here. Okay, and you'll see why I said there is a 6 edges. So A, B, C, D. Now, there is one A to B, B to C2, C to D3, 4. So no question about it, 4. And A to C, there is another one, 5. Now there is one B to D. Remember, if I do like this, B to D. So this one is just a line segment. It doesn't really intersect. Okay, so I can even put that way actually, as you see. So it's like, it's not overlapping. It's one breeze on top of another breeze. So this one is one breeze on top of another breeze. It's not a 3D. That's why we don't see. It seems like it's touching. It's connecting. No, it's not connecting. If you think of basically what do you call that, street breeze, you can easily find out. So this is not connecting. It's just going fussing another highway with another highway. So that makes it more sense, as you see. So in this case, you clearly see how many edges? 1, 2, 3, 4, 5, and 1 outside, 6 edges. Now it should make sense to everyone, right? Okay, now next thing we're going to learn what is reason. So reason, number of boxes connected by vertex inside the diagram plus 1 outside. So I just made this up actually. Let's take a look here. We can actually answer. Well, there is a standard formula actually. Let's put that formula here. Reason is equal to number of edges, take away number of vertex plus 2. That will give you a number of reason. So well, I'm going to use that concept, but first, have some example here. A, B, C. So clearly, how many, well, I can actually look into here actually, how many vertex, in this case is 3 vertex, how many edges, in this case is E represent edges, In this case it's also 3. And how many reason? Well, I can use the formula, or I can look into here. Look, one inside, another one is outside, so I can say 2. Just simple as like that. Or I can actually plug it in here. I can just plug it in here. So vertex, edge, and I can work it out. So how do I work it out? Edge in this case is 3 minus vertex is 3 plus 2, and of course is 2 reason. I don't really have to do this. I can easily do trial and error, look into that diagram and see how many boxes inside with node or points there. So there is going to be a situation you're going to get a little bit confused, and I'm going to make sure that you understand with some extra examples. Okay, let's erase this one here. I'm going to create another one actually. Okay, so if I have this one here, right, and if I have this one here, right, and this one here, A, B, C, D. So the same thing, the vertex is how many vertex? In this case is 1, 2, 3, 4, 5 vertex, 5 vertex, and number of edges. Let's take a look here. I see there is 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. I want to double check it actually here. Is this 9 edges? So 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. Yep, that's lovely. 9 edges. So how many regions are there? So look, 1, 2, 3, 4. Remember, that's all boxes with the node or points or vertex. 1, 2, 3, 4 inside, 5, and another one is outside. So it's going to be 6. It's going to be 6 reason. Well, does it make sense? You can plug it into the formula as you see down here, right? So you just plug that in here, okay? Believe me, you're going to see the same thing. So let's take a look here. Reason is equal to edge is 9 minus vertex is 5 plus 2. So 9 take away 5 is 4 plus 2 is 6. Bingo. Is almost same thing. Look at that. Is almost same thing. Alright. So we don't really have to remember this formula. As long as you see there is a number of boxes inside bounded by the vertex, you can easily find number of reason. Okay, so let's take a look here. I'm going to erase this here. I'm going to create another one. That is where some students get a little bit confused. All right, so let's take a look here. What is that one makes some confused student? Okay, so if I have this one diagonal and I have another diagonal, and of course this one up here, and clearly A, B, C, D. And I am going to actually work it out here. So number of vertex, as you clearly see, I'm going to have number of vertex in this case is 4. Look, 1, 2, 3, 4. Notice that I don't have any point up in the middle, so there is no vertex. So in this case is 4 vertex, clearly, right? And how many edges? Oh, by the way, B stands for vertex and E stands for edges. So edges, how many edges are there? So let's count. 1, 2, 3, 4, 5, 6, 7 edges in this case, by the way. This D to B, there's only one line, and A to C, there's only one line. Remember, this is not connecting, it's not overlapping, it's just going above one highway on top of another highway. Like crossing, when you drive, you go within a second, you cross one highway with another highway. This is just like that. It is 3D, you can easily see it, but well, it is not connecting. Seems like it's connecting. No, once it's dot, it's connecting, otherwise it's not connecting. Okay, so clearly in this case is 4, 5, 6, 7. So 7 edges are here. Okay, now number of reasons. So how many reasons are there? Clearly now I see there is one box, two box, and there is another one up there. You will see, this one is a little bit complicated as you see, and there is one here. So it's gonna be a little confused. I want to show you how and why it's confused. Okay, now I can make up one, and you will see this one here like that, and you will have actually better understanding actually. So this one, okay, and I can have this one down here, and this line I can actually work it out like this way. Okay, so there is a reason why I did that, so now you will have better understanding what's going on. So again, number of vertex is same, 4, number of edge is 7. Now how many reason? So you see 1, 2, 3, 4, and there should be 1, 5 reason. So clearly this is a 5 reason here. Or I can use the formula here. So what is the formula? Formula is reason is equal to edge minus the vertex plus 2. So what we have, edge is 7 minus 4 plus 2. So 7 minus 4 is 3 plus 2, and reason is equal to 5. Bingo. It works. Excellent. Okay, now the degree of the vertex. So what is the degree of the vertex? So let's take a look here. We can work it out here. Okay, so degree of the vertex. Okay, so the total number of line connecting the points or node is called the degree of the vertex. When we know the degree of the vertex, when we are able to actually find out degree of the vertex, we can actually find or easily trace a traversable network, and also we can easily find out whether it is a Euler network or Hamiltonian network. So this is very important. Okay, so let's take a look here. We're going to work it out. So this is going to be A, B, C. So degree of the vertex. So in this case, degree of A vertex is 2, C is 2, and B is 2. What does it mean? So I'm going to put down degree of the vertex. In this case, A is equal to 2, B is equal to also 2, C is also 2. Why is that? Because there is 2 line connecting. There is 2 line connecting A, 1, 2 line. This is 2 line connecting, this is 2 line connecting, so this is all even. Okay, now I can actually work out another one here. So A, B, C, D, E. Well, if I look into here, right? Well, number of vertices. Okay, degree of the vertices. Degree of the vertices. So B, how many line connecting? 2 line connecting. C, how many line connecting? 1, 2, 3. 1, 2, 3, 4 line connecting. So 4. And this is 2. This is 3. And this is 3. So that's how we find degree of the vertex. Okay, let's have another one if it is complicated, right? So another example, I can work it out here. You can make it as much as complicated as you want. Well, bottom line is, can you find it? Well, first of all, I have to label it so I know the degree of the vertex. A, B, C, D, E, F. You can label it anyway. So I have A, in this case, how many line connecting? 3 line. B, how many? 1, 2, 1, 2, 3, 4 line connecting. And this one is 2 line connecting, and C is 1, 2, 3, 4, 5 line connecting, and E is 2 line connecting, and D is 1, 2, 3, 4 line connecting. So clearly, as you see, those are the degree of the vertex. 1, 2, 3 line, 1, 2, 3, 4 line is connecting this point, so we call it degree of the vertex. In this case is 4. 1, 2 line, degree of the vertex in this case is 2, and 1, 2, 3, 4, 5, degree of the vertex is 5. 1, 2, and 1, 2, 3, 4, degree of the vertex is 4. So that is how we actually figure out degree of the vertex, and we can clearly see whether it is even or odd. So every time you have an odd number like 2, 3, 4, I'm sorry, apology, if you have 1, 3, 5, 7, that's odd degree of the vertex. If you have 4, 2, 6, this even degree of the vertex. And we have to recall those when you do the traceable, traversable, or Euler or Hamiltonian network. So we should recall those later on. Okay, good. Next, we're going to move into network. So what is network? So network is a graph that is connected with all the vertex. So all the line segments must be connected to form a box. So let's take a look here. This is a graph, when you have basically drawn some, well, let's take a look here. So this is a straight line. You have seen this when you do graph a linear equation. Okay, so you just find 3 point or dot and you connect them, then it becomes your graph. Now, this time, we are talking about the network. So it's like a social networking, social networking nowadays. You have a Facebook, Twitter, Instagram, Snapchat, you name it. Okay, so all you get connected with your friends, right? So this is basically the same thing. Network is basically a connection. So you connect one point to another point. So remember, this is, you connect at least one path. In order to be a network, it has to be at least one path from point A to point D and all you coming down. So this one is going to be now a network. This is a network. This is, down here is not, if I come off like that, this is not going to be network. This is a graph, but this is not a network. So I have to close this one off here actually, as you see. So this is going to be network. And if I do this one here like this also, so this is also a network. If I do this one down here like that, this is going to be also a network. Okay, this is going to be also a network. Notice that there is only one line coming down here. Okay, so as you see, these are the networks. So, but this is not a network. Remember again, not a network. This one is not a network. Not a network. Which one? This one is not a network. This one is network, this one is network, this one is network, this one is network. Okay. Now we're going to move into traversable network. So what is traversable network? A traceable network is said to be traversable if you can start tracing from one point without lifting the fan, ending in any point after tracing all the edges exactly once. Vertices may be passed through the point more than once. Okay, sometimes we don't really have to do all this. We're going to find a shortcut. So, the bottom line is here, if something is given, right, any graph is given, any network is given. So as you see, we said the network, right, is connected. Any network is given and you want to see, you can trace starting from one point, going through all the edges, it come back to the same point. Well, it doesn't have to be same point. You can come back anywhere, right? As long as you start anywhere. A to D to C to B, and you did go through all the edges, that's what matter. So you can cross the vertices more than once, okay, but edges only once. You cannot cross edges more than once. So clearly I see I can trace it. Yeah, I'm going to show you actually. Let's take a look here. Can I trace it? Look, A to D, D to C, C to B, B to A. I can even write path. How? I believe I said A to D. A to D, D to C, C to B, B to A. Or, you see, you know what? I'm going to do a different way. I'm going to say C to B to A to D to C. That's lovely. You can do that actually. Okay, you can do that clearly. You can actually connect your own. You're going to be creative. Okay. So now next one, I'm going to actually analyze this one here. So is this traceable? Is this a traversable? Let's take a look here. If I do try, let me see, I'm going to actually show you manually so we can understand whether we can trace it. So, I'm just opening this up. going down, trying to trace it, trying to trace it, trying to trace it, trying to trace it. Oops, which way I go? Should I go down or should I go other way? If I go down, oops, this one is left over, so I couldn't trace it. Well, I'm going to try another way actually. Look at this here. I'm going to try another way. Can I? So even the same way. Look, go down here, go down here, go down here. No, I cannot touch it one again. So I'm showing you all scenario down here. All the scenario. Still one left over. Okay, so I cannot do this here, right? So I'm going to try one more time actually. So if I do this way. No, this way you left two of them actually, as you see. So in other words, I checked out trial and error, right? I couldn't actually trace it. So this is not a traceable, not a traversable, not a traversable network. Whereas this one is, yes, this is a traversable network. Okay, so now I'm going to actually have more example here. Is this a traversable network? So clearly it is. Why? I can go from this point to that point and come back to this point. So A to B to C to A. That's the path. I can create more. Okay, so let me check it out this one then. So, well, I'm gonna do, let's see, I'm gonna do this way. Start here, go down here, here, okay, okay. Oh, yes, bingo, it is. So I'm gonna label it A, B, C, D, E. Okay, so the path would be E to D. You can do it manually. E to D, D to C, C to E, E to A, E to B, and B to C. That's the path. Okay, so this one is traversable. So I noticed that if I look into the vertex, right, so that was basically 2, that was basically 2, that was basically 2. So this is even degree. So obviously it seems like even degree gives you the traversable network. So how about this one? So this is 2, degree of the vertex is 2, degree of the vertex is 2, degree of the vertex in this case is 3, degree of the vertex is 2, degree of the vertex is 3. So seems like if I have exactly 2 odd vertices, that becomes our traversable network too. Okay, so in short I can say, if you see all the vertices are even degree or exactly 2 odd degree vertex, right, exactly 2 odd degree vertex or all even, then we call it is a traversable network. Okay, we call it traversable network. So here you go, guys. Is this a traversable network? So who can tell me? So first I am coming up with this actually. So this is 2, that's 2, B is 2, E is 2, F is 2, and this one is how many lines this point has? 4. All of them are even degrees. So by closing our eyes, if any network has even degree vertices, we call that is a traversable. So I can trace it. So well, how do I trace it? Can I? Yes, I can actually start anywhere. We don't have any problem here. Okay, I'm going to show you actually here. So I can go like this, just like that. Remember, I can go through the vertex more than once, but edges only once. Yep, I trace it. Now I'm going to actually work it out one problem where many of us make mistake here. So let's take a look here on this one. So okay, so this one, let me see, I can make it more. Okay, so I have 2, 4, 4, 2, 3, 3. Here you go. Let's take a look. This one. This is the vertex, this is the vertex, that's the vertex, this is a vertex, this is a vertex, this is a vertex. So what is the degree of the vertex? So I'm going to have A, B, C, D, E, F. Now our goal is to check whether we can find out the degree. So this is going to be 3, this is going to be 3, this is going to be 2, and that's going to be 4, and that's going to be 4, that's going to be 2. So seems like in this one I have even, odd, odd. So exactly 2 odd. So therefore by definition we will have a traversable network. So the problem is, how do we trace it? We have to do trial and error, but there is a quick way to do this. So let me show you what is that quick way. Okay, now we should always start with the odd vertices. Why? Because look, if there is a 3 line going up here from this to the left, and we need a 3 line in order to, if we have a 2 line, if we start in 2 line, if we start in 2 where, right, we try to connect 3, we're never going to be able to do that. So we need actually 3, 3. Okay, as you see, 3, 3. We need one more. So we need to start in any odds. If there is 2 exact odds, so we need to start in odd. You don't start in even. So we go with this one here. Another one, we work it out here. Okay, so we worked out another one, and of course this is going to be connected then. All right, as you see, this is going to be connected. All right, so I'm going to actually trace it on that one on the top. Okay, so if I trace it, it's going to be like that. So I'm going to start with the odd. I'm going to start with this one. You can start this odd, or you can start at that odd. Actually, it's up to you, any odd vertices. So this one, I'm going to start with A. So if I start with A, okay, so if I start with A, maybe I'm going to start with red color. So A to E, E to F, F to A, to B, to D, to E, to D, to C, to B. Look, I just trace it without lifting my pencil. So this is what called traversable network. Okay, without lifting the pencil, you go through all the edges exactly once. Vertices may be crossed more than once. Thank you.